Volcanic ash is striking our windshield at nearly 300 knots, a steady hiss that sounds like sand against steel. Engine temperatures are creeping upward, and our radar screen has gone blank. We are flying a 40-year-old C-130 into a blackout zone over Luzon. If the turbines ingest too much ash, they will flame out. There is no alternate field within safe gliding distance. The mission began 12 hours earlier at Villamor Air Base, where the Philippine Air Force assembled a quiet briefing. A major eruption from Mount Mayon had cut off several coastal municipalities. Ashfall grounded civilian aircraft and contaminated water supplies. Satellite images showed entire towns isolated by debris flows. Roads were impassable. Airlift was the only immediate solution. The cargo was straightforward but urgent: ventilators, burn kits, intravenous fluids, and palletized food packs. Several hospitals were operating on generators, struggling to treat respiratory injuries from inhaled ash. The eruption column was unpredictable, drifting westward with upper-level winds. Modern transports were committed elsewhere, leaving our aging C-130 as the only available aircraft with the range, payload capacity, and short-field performance required. Our aircraft had served for decades across typhoon relief and counterinsurgency operations. It was not new, but it was reliable when handled carefully. The maintenance crews inspected every intake, seal, and filter before departure. They knew volcanic ash was different from ordinary dust. It behaved like powdered glass, abrasive and conductive. Once airborne, there would be no room for mechanical surprises. We lifted off before dawn, climbing into clear skies that gave no hint of the hazard ahead. For the first 30 minutes, the flight felt routine. Manila Center handed us off to regional control. Weather reports described heavy ash concentrations above 20,000 feet near Albay. We planned to approach from the southwest, descending beneath the densest layer and navigating visually once we penetrated the haze. The transition was gradual at first. The horizon lost its sharpness. Blue faded into a dull gray band. Then the windshield began to tick softly, a faint scratching that intensified within minutes. Visibility dropped from 20 kilometers to less than 5. The sunlight dimmed as it filtered through smoke. We turned on anti-ice systems, not for ice, but to keep the engine inlets warm and reduce ash buildup. Inside the cockpit, the atmosphere tightened. The co-pilot monitored engine pressure ratios while I held altitude manually. The flight engineer leaned forward, scanning temperature gauges. Fine particles streaked across the glass, leaving faint arcs. We reduced power slightly to limit intake velocity. Every adjustment had consequences. Too little thrust, and we would lose climb performance. Too much, and the turbines would swallow more debris. As we approached the outer edge of the eruption zone, communications began to degrade. Static overwhelmed the radio. Air traffic control reported intermittent returns on radar. The volcanic plume was ionized, interfering with electromagnetic signals. Command had anticipated this. We were instructed to proceed under communication silence once contact became unreliable, maintaining a pre-brief corridor based on last known wind data and terrain charts. The radar displays flickered, then went dark. Transponder replies failed. We were effectively invisible to controllers. It was not secrecy for strategic reasons, but necessity. The ionized cloud distorted signals and produced false echoes. We switched to internal navigation references, cross-checking inertial data against estimated ground speed. Outside, the gray thickened, swallowing the coastline we had been using as a visual guide. Static electricity began to dance along the nose of the aircraft. Thin blue tendrils traced the propeller arcs, a clear case of St. Elmo's fire. The effect was unsettling but not unexpected. Charged particles built up along leading edges, discharging in faint glows. The co-pilot kept his voice steady as he read off altitudes. We avoided abrupt control inputs that could exacerbate structural stress. Soon our weather radar painted conflicting shapes. Ash clouds reflected differently than rain, creating distorted returns. The autopilot struggled to maintain stable inputs as pitot readings fluctuated. We made the decision to disengage automated systems entirely. From that moment, the aircraft was flown by hand. Control pressures felt heavier in the dense air. Every movement of the yoke required deliberate force. Engine temperatures rose steadily. The flight engineer reported a gradual increase in turbine inlet temperature across all four engines. Microscopic ash particles were entering the combustion chambers. At high heat, the glassy material could melt and adhere to turbine blades, disrupting airflow. We adjusted mixture and throttle carefully, seeking a balance between sufficient thrust and reduced thermal stress. A faint vibration developed along the left wing. Not violent, but noticeable. Compressor stalls were a real possibility if ash accumulation altered internal airflow. We implemented a modified throttle technique, easing power in small increments rather than abrupt changes. The goal was to prevent sudden pressure spikes. The engines responded sluggishly, as though burdened by invisible weight. Fuel consumption began to climb. Ash-laden air increased drag, and our lower altitude reduced efficiency. The engineer recalculated reserves against distance remaining. We had enough margin, but not comfort. Diverting was not an option. Nearby airfields were already coated in sediment and lacked runway inspections. Pressing forward was a safer choice compared to turning back through even thicker concentrations. Navigation shifted to dead reckoning. We relied on compass headings, estimated winds, and time-distance calculations. Luzon's terrain rose ahead, though invisible behind the gray veil. I reviewed topographical memory from previous relief missions. Mountain ridgelines near Albay could reach hazardous elevations if we drifted off course. Without radar altimeter reliability, terrain awareness depended on discipline and mental mapping. The psychological strain was constant but controlled. No one raised their voice. We spoke in concise updates. Every few seconds, eyes moved from instruments to the opaque windshield and back again. The sense of isolation intensified. There was no outside confirmation, no reassuring voice from air traffic control, only the steady hum of engines and the abrasive hiss against glass. At 17,000 feet, the ash concentration spiked. Visibility shrank to almost nothing. The sky and sea blended into a uniform gray. I initiated a gradual descent, searching for a lower layer where particles might be less dense. The co-pilot monitored vertical speed to avoid excessive sink rates. Descending too quickly could invite aerodynamic instability in the turbulent air. The gamble paid off. At 12,000 feet, the haze thinned slightly. Shapes emerged faintly below us, dark outlines of coastline and fields. Not clear, but distinguishable. We adjusted heading 5 degrees east to remain within our planned corridor. Lightning flickered within the upper plume behind us, reminding us that the eruption column remained active and unpredictable. Approach planning had to be visual only. The designated landing strip was an auxiliary airfield near Legazpi, partially cleared by local engineers. Ash covered the runway in uneven layers. Braking performance would be reduced. We briefed a shallow descent profile, maintaining higher than usual approach speed to compensate for potential engine response lag. Go-around capability was uncertain under these conditions. As we descended through 8,000 feet, the coastline became clearer. The ash cloud trailed behind us like a wall. Sunlight filtered weakly through suspended particles, casting a muted glow over the terrain. I could see patches of gray coating rooftops and trees. The eruption had reshaped the landscape, turning familiar landmarks into monochrome silhouettes. Final approach required complete concentration. We flew slightly above normal glide slope, prepared for sudden downdrafts. The runway appeared as a darker strip amid lighter sediment. There were no electronic landing aids available. I relied on visual cues and peripheral alignment with the shoreline. The co-pilot called out altitude steadily, his tone measured and precise. Touchdown was firm but controlled. The tires met ash-covered pavement with a muted thud. Reverse thrust was applied cautiously to avoid ingesting additional debris. Braking action felt uneven but manageable. We rolled to a stop near a cluster of emergency vehicles partially obscured by dust. Only then did the crew allow themselves a brief exhale. Ground crews approached wearing protective masks and goggles. The aircraft's fuselage bore visible streaks where ash had sandblasted the paint. Leading edges appeared dull, stripped of their usual sheen. Despite the wear, all 4 engines remained operational. That fact alone justified the calculated risk taken in the air. Cargo unloading began immediately. Pallets of medical equipment were transferred to waiting trucks headed toward evacuation centers. Local responders moved with urgency but discipline. Many had been working without rest since the eruption intensified. Their focus was not on the aircraft but on the supplies inside it. A provincial health officer briefed us quickly. Respiratory cases were rising, especially among children and elderly residents. Clean water distribution had become critical. The ventilators we carried would stabilize patients suffering from severe ash inhalation. Hearing that reinforced the weight of the flight. The risk in the air translated directly into lives on the ground. While unloading continued, our flight engineer conducted an exterior walk-around. He documented erosion along propeller blades and minor pitting on engine inlets. Filters would need replacement before departure. Maintenance teams at base were already preparing for intensive inspection. The aircraft had endured conditions beyond standard operating environments, but it had held together. Refueling was limited. Contaminated fuel was concerned, so we relied on sealed reserves transported with us. The return leg would require another transit through residual ash, though forecasts suggested gradual dispersion. Command authorized extraction once cargo transfer was complete. There would be no extended ground time. Before departure, I stood briefly at the base of the ramp. The air tasted metallic. Fine particles settled on uniforms and equipment. In the distance, Mount Mayon continued to release a steady column, indifferent to the disruption below. Nature operated on its own scale. Our role was simply to mitigate its impact where possible. Takeoff from the ash-covered runway demanded careful throttle control. Engines spooled gradually, avoiding sudden surges. The aircraft accelerated, lifting through a thinner layer of haze. As we climbed, sunlight strengthened. Communications gradually returned, first as faint static, then as clear voice contact with regional control. We reported successful delivery and stable engine performance. Hours later, approaching Manila, the aircraft felt heavier in memory than in weight. The margin for error had been narrowed, but measured decisions had preserved both crew and cargo. The mission would not dominate headlines. Yet in the hospitals of Albay, equipment was running and patients were breathing easier. Sometimes resilience is quiet, carried on aging wings through uncertain skies.